Can Weka replace Python and SQL? Well, this is, let's say there's no really need to use Weka to replace Python and SQL because they are for different purposes. Yeah, for those you don't know how to do programming, then Weka solve the problem for them without them running away from machine learning. You see, the idea of Weka is you can quickly do modeling without even knowing how to write a single code. See, and you can do data analytics with it. You can also do research, especially researchers. So you see a lot of people who want to learn machine learning to use it for their research, or they have to start learning Python. Along the way, they lose interest because coding is another thing, machine learning is another thing. It's totally that different concepts. You don't need to be a programmer to use machine learning. So this is why we recommend for newcomers and people who are not computer oriented to use Weka. And even people who are computer oriented, they also use Weka. That is fine. However, Python is a programming environment that also provides you with the opportunity to do a lot of machine learning experiments using free softwares. We have a lot of open source softwares. We also have R. We have MATLAB. There are so many programming languages. That is why that's the questioner. I know why the questioner is specific about Python. Python is not the only programming language. We have so many programming languages, and different companies prefer different programming languages depending on the problem they are solving. And each programming language also portends their own challenges and advantages. However, Python is getting really very popular. So if anyone wants to go for programming languages for machine learning, I recommend Python very well for them. And also SQL is another thing entirely. So it has its own way of working, especially when it comes to data wrangling and some other data manipulation. The SQL can come in, but SQL and Python, they are not the same thing. Of course, we can use them, we can link them together depending on the problem we want to use them to solve. But as for using Weka to replace Python and SQL, it depends on what you want to do. Actually, if you are a researcher, you don't need SQL to do your modeling. By the way, you are a researcher, you don't know how to do programming, you are okay with your Weka or any other click and use or GUI-based machine learning that doesn't need programming. But for programmer, you want to work for a company that needs you to write a code in Python, for sure, you cannot use Weka to do that because they have their specific needs, which is that you need to learn how to use Python. While some company will ask you to know how to use R. R is another very popular machine learning, very popular programming language that supports a lot of machine learning programming. We also have the big MATLAB, you see, and a host of others. So, however, the idea is that we don't want people to get discouraged about machine learning just because they don't know programming. And in essence, you can do a lot of work with Python, with MATLAB, with R, and even with Weka and other platforms. So people don't know programming languages. In order not to discourage them from using machine learning, like I said, I called my term machine learning for all. Everybody should be able to use it. It's like a tool. It's just like these common statistical tools before, like SPSS. But machine learning is now better than statistical tools. So people who are using SPSS before, they should be able to migrate to using machine learning without the trouble of having to learn how to program. So this is the idea of machine learning without coding. And the idea is getting very popular these days. Even Harvard now have a particular section of the program dedicated to training people on how to use machine learning without coding. So the idea is not to replace Weka not to use Weka to replace Python. It depends on what needs you are in. If you really need to do programming for machine learning, that's great. And one of the other motivation is this: you need to know machine learning concept first. Once you know it and you know how to practice it using simple tools like Weka, then your interest now can push you to move further to now learn other programming languages like Python, like R, like MATLAB, so that you can take your machine learning to another level entirely. Yeah, because when you program, you have the opportunity of going inside it and manipulate data, do some stuff that people using Weka might not be able to do. But if you have to start with something that you need to, that might discourage you, practically from my engagement with people, I've seen a lot of people starting machine learning with Python, but along the way, they have to drop out of that course because they feel Python is very difficult for them to know. And I can understand their situation because Python is about programming. Machine learning is not about programming. So if you can do machine learning without programming, why do I need to use programming to discourage you from learning these very interesting and important new tools that can really take you to new places, especially in your various areas of specialization. So this is the idea of using Weka for the meantime. So people want to explore Python, who have the opportunity also as we move on, and it's highly encouraged for people who are programming inclined. Now, can Weka be utilized for NLP tasks like sentiment analysis of tweet? Yes. I've had one of my master students graduated using Weka to do NLP. She worked on a sentiment analysis of Arabic text, and it was totally done using Weka. Weka has a lot of capability. In the past, Weka doesn't support deep learning, but now it has supported deep learning. You can import deep learning into your Weka and you do a lot of things with it. Yeah. So the answer is yes to this question. Weka can be utilized to do natural language processing, tasks like sentiment analysis of tweets and others. And I've had students who actually demonstrated by using it for master thesis. Is it possible to calculate the relative contribution of each features? This will enable identified features to be retained and the one to be discarded. Yeah, it is possible to calculate the relative contribution of each features. You see, when you have, this is what we call feature selection. There is a whole, we've added several, maybe few lectures section on feature selection. It's very important that different types of feature selection. So this is where we try to let the data speak, See, when you want to do modeling, first of all, you start with the original data. Do modeling using the original data. Let the data speak. Let's see what you can get from it. See, let's see what you can get from it. So the next thing is, after maybe you have like the example we shown to us. So let's say we have this data set. We have this data set. We have loaded it into this system. I'm going to show it now. We loaded this data in. This data, that data, trying to predict diabetes using a questionnaire. You can see we have here 16 questions. So running this experiment now, using KNN, we were able to get 98% accuracy. Wow, excellent. Can you see 98% accuracy? See, is it using lazy classifier? We got 93. Voting will always give you better result. 98 from voting. We are coming back to that, by the way. Now, so we are getting 93%. So can we reduce the feature? Imagine you have a questionnaire for someone who is very busy. So feature selection is trying, can we reduce the number of features to like 3, 4, 5, or 6? So we try, and what is the contribution of this? What is the contribution of this? We try to check their contribution. So can we select which of them will be best? You see? So the idea could be more complicated. That's why in feature selection, we have univariate feature selection. In univariate, we try to understand what is the contribution of this to the predicted class. What of these on individual basis? But sometimes we need to do multivariate feature selection. That is, we want to consider multiple features at the same time. Because sometimes age and itching, when you combine the two together, they might give you a very good job, very high result. What if I put irritability and remove itching? It goes down. Okay, I remove itching, I put partial paresis and age. It increased. Sometimes you need to multivariate feature selection is an option. So whereby we try to see different features from different angles and see how can they really support us to get better results. Yeah. So one of the way you can get a quick contribution of each feature is what there are many methods, but a very simple one is what I call correlation coefficient. Correlation coefficient. So try to calculate the correlation coefficient, see what you can get. So maybe this correlation coefficient for the first one is 0.95, the second one is 0.96, 0.96, another one is 0.92, another is 0.01, which means it's very low. But sometimes this lower one, if you combine it with this one, maybe the two of them will get better result than when you combine these two together. You see? So that is why feature selection is a whole topic on its own, but definitely having a way to calculate the relative contribution of each feature will enable us to identify features to be retained and the one to be discarded. Yes, this is exactly what we do when we talk of feature selection, and it's highly recommended for us because sometimes all the features, they might not be able to give us better results, especially when you go to study, look at the video where I talk about cause of dimensionality. Cause of dimensionality. You see, it's a very challenging area that we are going to have the opportunity again to look at again. And you can also check our video on that. The more the number of features, the more the number of samples we need to get reasonable results. But the reality is our samples are usually limited. We can't increase the sample because this is all what the client can supply. So what do we do in that case? We have to bring down the number of features. How do we bring them down? Is it random? No. We try to see features that we make better contribution to the system we want to generate so that we can know which one to drop and which one not to drop. But it's as simple as saying, but it's a little bit more complicated because we have different methods of feature selection. Univariate, where you consider each of the features separate, and multivariate, whereby we look at group of features. Because there are two people, a brother, two senior brother, junior brother, if you put them together in the same group to work for you, they might do great job. But if you bring one of the brother out and put another guy, very brilliant from another group, they might not be able to work for you because maybe they are not flowing well, or maybe they talk too much when they're together. It means these two features, they are not compatible with themselves. So this is what we study under feature selection. And I recommend that we look into the video on feature selection. We've described them in details, how to do feature selection, how we might need it. And we also demonstrated also in some of our previous lectures where we discuss real-life modeling and problem solving. Use Weka for ensemble model? Yes, we can use Weka for ensemble model. And until I've shown it today, we have several system in Weka, and specifically again, for the sake of people who might miss the earlier part, this is Weka. You can see Weka here. When you go to classify, choose here, this meta. You can see here, meta. Everything inside the meta is all about ensemble. You see, click it. So try to, yeah, adables, additive regression, attribute selected classifier, bagging, stacking, votes, weighted distance, everything here, they are all about ensemble method. So Weka support ensemble. Is Weka an open source software? Yes, it is open source. So yeah, it's freely available for everybody to pick. And it's one of the contributors to the open source software. Because of the high cost of software, people come together in the open source principle so that we can make software available for people at no cost. Yes, of course, people want to use it for high-level businesses. You need support from the developer. This is where the developer make their own money because they are going to support you because you need special support because it's a kind of institutional use. Of course, it's provided for you for free, but then you may need some support to be able to understand them in details. But for sure, Weka is an open source software and very powerful and very useful, especially for people who don't know programming and they still want to use machine learning. How to select the ANN algorithm in Weka? Yeah, an algorithm is weak in weaker, just like any other algorithm is there. We can just go here. See, sorry. So you go to classify, choose, you go to function, here, you can see them there. This is multi-layer perceptron. You can put it here. Like I tell you, you just put your mouse on it, it will tell you what is it. A classifier that uses back propagation to learn a multi-layer perceptron to classify instance. If you want to know what any model, any algorithm is all about, just hover your mouse on it, it will show you the description. So this is neural network. We call it multi-layer perceptron. See, it's neural network in a weaker environment. So you just click it, and then it's loaded already. I start it. I've just built a model using my neural network for this. It's taking a little bit of time. It's not yet finished. Yeah, because neural network takes a little bit of time because of different layers, depending on the number of layers you have set, and also for that. So the answer is yes. So we have demonstrated how to select neural network. It is under the function. You go to function in weaker under classify, and you select multi-layer perceptron. That is the name of neural network in weaker. Please, can you give me some scenario of ML in computer networks? Yeah, so computer networks, an area that so many, a lot of application area that machine learning could be put into them. So among them is you want to really predict or to analyze network. So either what is the performance of the network, depending on the type of network you're having, is it a local area, is it distributed? You can be able to pinpoint where there is a problem in the network. You see, this is one of the area, you have a lot of data in the system. You can use the data to build it to be able to detect where there's a real life problem on the network. You can quickly detect it. If there's an issue in the network, which machine is causing that particular system? To either there's a clogging in the network because some people are setting some packet that's not necessary. So we call it denial of service. Denial of service is a decision whereby some people started sending useless information to the system so that other people with useful information will not be able to get their information delivered. So they want to deny you service by repeatedly sending useless things. So we can develop machine learning that can pinpoint which machine is responsible for this quickly so that you can bring such a machine down in the network before it causes a lot of problem. So for sure, computer network is a very big area with a lot of application of machine learning, especially when you want to go to the security aspect of the cyber security of it, so that your network can be stable. Which network node, if you want to even design network, what is the configuration that we should use for our network? That will be better. You can use previous data to simulate and be able to predict or identify some of the best scenarios that you can bring out in the computer network. And host of other application area of computer network that we can actually subject machine learning to. So I want to believe this should be, this will be the last question for the summer school. So, and I hope we have provided answers to some of these questions. So if there's any particular detail we feel is missing, so let us feel free to engage, contact us through the provided numbers and WhatsApp. We'll definitely be more willing to provide further guidance in this respect. And anyone that is interested in some of those areas specifically, you're all welcome to the weekly classes so that we make on every Saturday. So where we have the opportunity to clarify things for ourselves. So once again, thank you all. So that's all we're gonna have regarding answering questions to the answering question raised during the 3 days summer school. So thank you all for making it reality and keeping it there. So I wish everyone all the best, and thank you for coming.